Oh, hello there, coding enthusiasts and fellow digital adventurers. It's me, the Web3 idiot, your trusty guide in the world of self-taught programming. Today, we're embarking on a thrilling quest into the enchanting realm of merge sort, a magical way to turn chaos into order, one piece at a time. Now imagine you have a pile of jigsaw puzzle pieces, each scattered far and wide. What do? You merge them together, of course. Merge sort is like the puzzle-solving champion of algorithms, bringing harmony and clarity to the chaos. Ever cleaned up a messy room or organized your workspace? Well, you've already taken the first step into the world of merge sort. It's all about taking scattered elements, arranging them neatly, just like tidying up your favorite room. Feeling like algorithms are a maze without a map? Don't worry, we've all been there. Our mission today is to break through the complexity, making merge sort feel as easy as connecting the dots. Are you ready to unlock the secrets of merge sort? Witness the magic of merging and master the art of sorting. By the end of this video, you'll be sorting like a pro and have another powerful tool in your coding arsenal. Without further ado, let's dive into the captivating world of merge sort, where disorder transforms into harmony. The journey is about to begin. Hey, yay! So today we're taking a look at merge sort. Merge sort is probably the best way to sort your arrays. It is has the best time complexity, best space complexity compared to the three previous sorting algorithms we looked at. If you remember, those had a time complexity of n squared, but this one, it's a bit better, I'm going to say. Same space complexity, but the actual algorithm itself is a bit better. So what exactly is merge sort? So let's go ahead, let's use our classic example. This time, we'll go with 8, 7, 6, 5, 4, 3, 2, 1. And what we want to get is 1, 2, 3, 4, 5, 6, 7, and 8. So that is the output we want. Oh, that's where we're off a little bit. 1, 2, 3, 4, 5, 6, 7, 8. 8, 7, 6, 5, 4, 3. Oh, there we go. We're missing a 4 here. Let's actually make this a little bit harder, actually. Okay, we'll go 8. 6, 4, 2, 7, 5, 3, 1. There we go. A little bit more challenging. So the idea is we take this input and we receive it unsorted and we output it in a sorted manner. So merge sort is it's pretty cool. What it does is it involves merging and sorting, just as the name implies. So we're going to split this up real quick. So what happens is we take this array and we get it down to its lowest element, and then we merge those two together. What does that mean? All right, so here we go. What we do is here, this will come down here, and it will split in half. Like this. So now we have 4 on this side, 4 on this side, and then we'll take this again on this side and we'll split it in half. Oops. Put it there. 1, 2, 1, 2, 3, 4. And then we'll move that over a little bit more. And then once again, we will take this. Oh, oopsies. What am I doing? Drop it down to here. Boom. Boom. So now we have 2 arrays at the lowest level of length 1. So what we do is, this is where it happens. This is where the merge sort happens. We take these 2. We say, oh, this 8, it's less than the 6. So we're going to put the 6 up here instead, and we'll put the 8 over here. And now this is gone. We'll do the same for this down here. Boom, boom. Those are split up a bit. we say, oh, look at this array of 1 and this array of 1. This array of 1 is 4. It is less than this. So we put 2 here, and we put 4 here. And then, boom, this is gone. Bye-bye. Then we look at this array of 2 and this array of 2. They are both sorted. So we say this 6 to this 2. This 2 is less. We'll put it here. Then we move over here. We look at this. We say, is this 6 less than this 4? No, it is not. This 4 goes here. And then we look at this 6. It is compared to nothing. We put it here. This 8, we put it here. And these are now gone. Bye-bye. And then we have to do the same thing for this set of arrays over here. Put it there. I'm trying to go as fast as I can. So this is divided up into 2 arrays of 2. Then we'll look at this one on this side first. Whoopsies. What am I doing? We'll put that there. Split it apart. And we'll look at this again. We'll say, is this 7 less than this 5? No, it is not. We'll put the 5 here. Is this 7 less than... There's nothing to compare it to, so we'll put it here. 7 goes there. Boom. Bye-bye. This, we'll take this 3 and this 1. Put it down here. Boom. Boom, boom, boom. Boom, boom. All right. So we have this 3 and this 1. We say this 1 is less than 3, so we'll put it here. This 3 goes after that. Boom, there we go. All right. Then we will look at these 2. We'll say, we'll compare the 5 and the 1. The 1 is less than the 5. We'll put it there. Good. Then we look at the 3 and the 5. Okay, the 3 is less. We put the 3 there. Then we look at the 5 to nothing. Nothing to compare it to, so we'll slide it in there. Then we look at the 7, compare it to nothing. Slide it in there. And these are complete. Bye-bye. And then we will compare these 2 arrays of size 4. So this 1 compared to this 2 will go here. Good. This 2 compared to this 3 will go here. Good. This 3 compared to this 4 will go here. Good. This 4 to this 5. Good. This 5 to the 6. Oops. Nope. The 6 to the 7. The 7 to the 8. And 8 is compared to nothing, so will automatically be placed, not 9, there. And we end up with a sorted array. It is pretty great, and it's amazing. So how we're going to do this is we're going to use a thing called a recursive call in order to get down to the lowest level. This is a pretty, I guess, pretty high level thinking, but we'll try and break it down as low as possible. So pros, here we go. Pros, it is fast. Cons, no cons. It is the best. It's the best version. So pretty much no cons. Yeah. This is the best sorting algorithm you could use. So here's what we're going to do. We're going to have, I guess, 2 functions, more or less. We're going to have a merge sort function, and we're going to have an offshoot called a merge function. So inside this one, this is going to be our recursive call. So a recursive call is just a fancy way of saying a function that calls itself until it meets a specific requirement. So our specific requirement is if we pass in an array here, and we pass in 2 arrays here, array 1 and array 2. So if array length is equal to 1, then we will return the array. That is what we do. We will return the array. But you got to think, what if it's an odd number of elements in our array? We have to say if it is less than or equal to 1, because we make it an array of size 0. All right, if array length is less than or equal to 1, well, we probably will never get a size 0, but just going to be safe. We'll return the array. So that is what we did when we got down to this part here, when we got down to 8 and 6. That is our array size 1 is 8 and our array size 1 of 6. So what we do is every time we are given an array, we have to find the middle. Find the middle. So here, the middle was this 2, right? So what we're going to do is split in half. Left equals, we need a left array and a right array. Next, what we want to do is we will call merge on, of course, this merge down here. Before we do that, actually, we want to go up here and say, we want to call merge sort on the left and merge sort on the right in order to get down to this break case of array size 1 or less. And then for these two, these will provide array 2 and array 1. So that is where we do this merge. Boom, boom. And we want to return that. So there, what we're going to do is a simple for loop, I guess. Well, I guess we'll do a while loop. Why not? Let's do a while loop. So we could say while well, actually, what we want to do is create an output first, initialize an output, and then we'll keep track of the left init left pointer, init right pointer, and then down here we'll do a slide on down. Down here we'll do a while loop. For this one, in which case we say while array 1 left pointer is less than array as long as while loop array 1 left pointer is less than array 1 length, and right pointer is less than array 2 length. Then what we want to do is check if array 1 at left pointer is less than array 2 at right pointer. Then what do we want to do? We want to say result or output push array 1 left pointer. All right, there's that. And then we want to increase our left pointer. Left pointer increments by 1. And then else, we will say output push array to right pointer and right pointer increments by 1. Boom, boom, boom. Not too bad. And then what we want to do is return the output. And what else do we want to do? We want to concat the remainder of left or right. So one of them will be left over when we get there, and that is where we will concat it and return it. So yeah, time complexity is log n because of it is a halving every time. We go to every number at one time, and then we multiply it by a half of every time. So that's the log n. And the space complexity would be n as well, similar to your other sorting algorithms. So let's go ahead and code this up. Why not? Here we go. We'll do a function. Here we'll go merge sort, and inside we'll pass it an array. All right, so we'll pass it an array, and we'll go ahead and write our first break case, okay? Our first break case, which would be if array.length, what do we say up here? Up here, less than or equal to 1, we will return the array. Is less than or equal to 1, then we will say return array, because that is our base case. That is where we want to break out of this recursive call. Next, what we want to do is we want to find the middle point. So we'll say constant middle is equal to math.floor, and we'll go array.length, and of course we want to find the middle divided by 2. We're doing a floor because it may be odd and we don't want to get a 0.5 in there because that will not pick up anything. Next we'll say constant left is equal to array.slice, and inside we'll pass 0, that is our start, and middle, that is where we will end, but we will not include it. All right, and finally we have a const right equals array.slice, and what we want to do is we want to get the rest of the middle from the rest of the array from the middle out. Middle out, yeah, good old middle out. Next up, what we want to do is we want to call a recursive call on both of these. So we'll say constant left sort, left sorted. We'll call that merge sort, and in there we'll pass in the left. So again, that is just breaking down one at a time. So we pass in this, and then we pass, so we pass in, this is our first left, this is our second left, and then our last left is 8. That will return an 8. And then we'll do the same thing with the sorting of the right. Let right sorted equal merge sort of right. Boom, boom. So again, we go left, 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 and we get, oh no, sorry. What am I doing? Left, left, left. This is the bottom. It breaks out and it jumps back up to this, and we pass in the right here. So then we compare 8 and 6. Ba-bam. And then what we want to do is we have 2 sorted arrays, array 8 and the array of 6. Both of these are length 1, so they are automatically sorted. And what we want to do is we want to return merge of left sorted and right sorted. And that is where we, not merge, sort, sorry. Down here, we will create our new function called merge. And inside we'll pass in a left and a right. So there's the left side and the right side. Next up, let output equals an empty array. This is where we are outputting our sorted elements. And we'll have a pointer for let left pointer equal 0. We will start at the 0 index of both sides, and let right pointer equal 0 as well. And then here is where the fun begins. We do a while. So again, let's come up here. Let's take a look here. While the left pointer is less than the left length and the right pointer is less than the right length. So while left pointer is less than left dot length and right pointer is less than right dot length. Pretty easy, pretty straightforward. Then we do a comparison. If left at left pointer is less than right at right pointer, then what we do is output dot push And what we want to do is push the left at left pointer. Pretty good. And then over here, we'll do left pointer increments by 1. Else, what we want to do is do output dot push, and this is when right is greater than or less than or equal to left. Right at right pointer. And then we also want to increment right pointer plus plus. All right, very good. Not too bad. And then what do we want to do is our last line up here, return output concatenating the remainder of left or right. So we don't know at this point if there's a remainder on the left side or the right side of the array. So what we're going to do is just pass in slices using the index that we are at, or the pointer that we are at. So we'll say return output dot concat. And what we're doing is left dot slice. We're passing in a slice starting at the left pointer. So if you are keeping up, if the left pointer is beyond the bounds, we're not passing anything in. Same thing with the right dot slice of the right pointer. And that is just passing in the remainder of either one of these. So this takes into account if there's a remainder on the left side, we pass in the left, and if there's not a remainder, this will just pass nothing in. Same thing the other way around. And yeah, that should be our code. Let's go ahead, get up a test array. Let test array equal, we'll pass in 8, 6, 4, 2, 7, 5, 3, 1. And what we're expecting is 1, 2, 3, 4, 5, 6, 7, 8. Console.log, and inside we'll pass in merge sort, and in that merge sort we'll pass in the test array. Now over here we're expecting to get 1, 2, 3, 4, 5, 6, 7, 8. Let's go ahead and test it out. 1, 2, 3, 4, 5, 6, 7, 8. All right, let's add in a odd number of elements just to make sure that it takes into account this. Ba-bam. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, very good. So just to run through this one more time, with our merge sort, what we do is we pass in this. We call merge sort on left, which would be this, and merge sort on right over here. So we first go through the left side first, then we pass in left, and then we pass left again. We pair this one to this one. Good, we have 2 sorted arrays of length 1. We put them into this function here called merge. 6 gets passed into the output, then 8. And we pass out an array of 6 and 8 in that order. Do the same thing with 4 and 2. With arrays of length 1 on 4 and array of length 1 on 2. We pass those into the merge. Then we get a 2 and 4 array with the length 2. Then we compare the 2 and 4 and the 6 and 8. And we pass up 2, 4, 6, 8. That is our left side here. In which case we move on to the right side of the original array. So we pass down 7, 5, 3, 1, 9. We pass left 7, 5. We get 7 in an array of 5. Then we pass up 5, 7. We compare it to 3, 1, 9. We pass it down. We have a 3, a 1, 9. And then we pass down 1, 9 down. We compare 1 to 9. 1 is less. Then we pass up 1, 9. Compare it to 3. We go 1, 3, 9. Pass it up. Compare it to 5, 7. We'll get 1, 3, 5, 7, 9. And then we have our right side up on the original array call. And we pass those in to this merge here. So we'll compare 1, 3, 5, 7, 9 to 2, 4, 6, 8. And our output will be 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, very good. That was just a quick rundown. If you have any questions about merge sort, leave them in the comments. Again, I'm just trying my best to help everyone in the community. I've had a lot of help from other people, and people in the self-taught would not get to where they are if it weren't for the help of others. So I'm just trying to get back to the community. And if you have any questions, I will do my best to help you out. Anyways, thank you so much. I've been the Web3 Idiot. Have a great day.